Yeah, so hey everyone, sorry about that. So yeah, my name is Jack. I work at Google on the Chrome DevTools. So if you've ever popped up inspect element in Chrome, that's the bit I work on. And yeah, I want to talk today about some of the lessons I've learned from maintaining really the largest code base that I've ever worked on in my career so far. So just to tell you, if you're interested, the DevTools are actually open source. It's not sort of internal to Google. So if you are ever curious at how it works, it is just a regular web app, albeit quite a big, complicated one in places. But you can go online, you can clone it locally, you could run it locally, you can make changes. We do, in fact, get contributions from people outside of Google. So if you're ever curious or you want to look after this, you can find it there as well. And feel free to ping me if you have any particular questions on it. So just give you an idea, when I say large code base, large to me and what that kind of means, there's about 150,000 lines of what we call first-party JavaScript. So that's JavaScript that we have authored ourselves. If you then include some of the kind of node dependencies and other things, you're talking, I think, close to 500,000 all in. So it's fairly hefty across a lot of different files. But when I say large, it's not just the fact that there are lots of lines of code, is that there's just a lot of history in the code base. It's, I think, over 15 years old. It started off as kind of in the Apple browser in WebKit land. Some of you might remember when it sort of, there were all the like browser engine wars, and there was WebKit, and then there was Blink, and then there was Google contributed, all sorts of history there, a load of different people from loads of different teams contributing to the code base, a real mix of styles. And one of the things that's really important to us is that we ship DevTools daily into Chrome Canary. So if you're using Chrome, you're probably using the Chrome stable build, which I think is released every 6-ish weeks. But Chrome Canary is released every single day with the changes that happened the previous day. And so there's a lot of pressure there because people do use Chrome Canary. And if we break that, that's people who can't debug their websites in Canary. So it's a double-edged sword. You find out if you've broken things really quickly. So that's quite nice. But you do also get a lot of people telling you that you've broken things really quickly. So it's sometimes nice, and other times you get some people a bit frustrated at you. So what I want to talk to today is just go through some things I've learned that I've kind of found particularly matter when working on a large code base. What I'd hope as well is that these lessons don't only apply to code bases of this size. I think all of these lessons can be applied to smaller code bases and probably help them kind of stay in a good state as code bases grow. So the first thing I want to talk about is that if it's not tested, it's probably broken. And what I mean by this is that if you haven't got some form of automatic tests, making sure all the different features of your application are working, there's a very high chance, particularly as you think about the number of people contributing to a given code base, that something breaks. Chris touched upon this when he was talking about linting previously, but when we upload a change onto our sort of the Chromium system, which to be honest, looks very different too, but you can think of this just like a GitHub pull request. It's just what the version we use looks like. Loads of automatic checks run. We check our unit tests. You'll see in there a lint check with ESLint as well. There's all sorts of various tests that go on. You can see it takes a good 10-15 minutes, which is the downside of doing all these tests. But if these all go green, if we get those nice ticks, we can be pretty confident that this change hasn't broken anything, or at least hasn't broken a core bit of functionality. So our checks range from things like using the TypeScript compiler. Does the code base even compile? Have we got errors there? ESLint, as Chris mentioned, we've planned this perfectly. Is the code up to date with sort of our style? Does it fit our style guide? Unit tests for does it functionally work? And then we have end-to-end tests. End-to-end tests actually fire up the dev tools and act like a user would. So they click buttons, they type into inputs, they hit enter, and they make sure that what the user sees looks exactly like we would expect it to. So by the time I've uploaded the change and all these ticks have happened, I'm pretty confident that I haven't done anything drastically to break. And you would be amazed how many times I've made a quick change, just done a quick bug fix, thinking this won't break anything. There are no consequences to doing this. It's not going to negatively impact anything. And one of these checks goes wrong and catches something for me. These are sort of things you don't necessarily think you need, but when it stops you pushing out a change that will have broken a core workflow, you'll be very glad that you've got all this stuff in place. Another thing that actually helps with the previous step in terms of reducing the risk of you breaking stuff is if you can isolate your code base into modules. What I mean by modules here isn't necessarily one JavaScript file, but you take all related functionality and you group it into a sort of folder or subfolder in your repository. And that folder can then be worked on relatively easily in isolation from another folder. So DevTools is big. There's a lot of functionality. There's a lot of features in there. And we also have a lot of people working on it. So we have the code base here represented for some reason by a house. Not sure why I went for a house, but go with me. And we have all the developers contributing to this. And they will all be working on different features. They'll have different things going on. One maybe is doing a bug fix. One's adding a new feature. One's writing some tests or some documentation. And at any point in the day, their changes might land into the main code base. They might be merged. But if you're all working in sort of the same set of folders, you're probably going to conflict with those people quite a lot. We've all been there when we've pulled down some code or we've merged in a branch and you get the dreaded merge conflict in some file that you now need to go and fix. Ultimately, this will happen sometimes, and that's one of the reasons we use version control like Git, is to catch these and let us deal with it. But if you can structure your code so that each person who's working in an area can work fairly confidently without conflicting with people working in different areas of the application, you're going to hit this less often. And it makes us sad if you hit this all the time. Particularly if you're working on a big feature, you're pulling in changes, you keep getting endless conflicts. It's pretty hard to build up momentum to work on that feature. And honestly, Chris, it's like we actually spoke ahead of time about these presentations, because I've really, I'm able to play off yours really nicely. But one thing I've really learned, particularly with a big team of people working, is that if you don't enforce some standard, it's not going to be followed. So you've got people committing code to the code base all the time. We've got people doing it across different time zones as well. So it's not even like you can always be online to keep an eye on things. There's just far too much happening at all hours to make sure no one can manually check that all the code is good. It's just too much work to do. So what we want to do is make sure we can maintain those standards. We mentioned ESLint already. And so what we need to do is make sure that the changes that match our standards make it into the code base. We need to make sure the ones that don't, the developer gets told so they can go back and fix those issues. We use linting for this incredibly aggressively. If we decide that we want to follow some new convention, it pretty much has to have a lint rule attached to it or some check to enforce it, else it's just not going to happen. And that's not because my colleagues don't want to follow conventions. It's not because me or anyone else on the team deliberately tries to, do things the wrong way. It's just there's a lot going on. It's very easy to forget that we introduced a new stylistic preference last week. Or, hey, everyone, could you please try to remember to do this? People won't remember to do that. And that's me included. I'm not saying that I don't do these too. You have to have enforced checks via ESLint, TypeScript, whatever it may be. So we have loads of checks. As I mentioned, the ESLint built-in rules. We then write a lot of ESLint custom rules. So you can write your own rules that sort of hook into the ESLint API to write sort of pretty niche specific checks that you need to check. We have what we call pre-submit checks. These run when you open a change. And this is like, are all the internationalization sort of generated strings we have, or localization stuff, or various things, are these all up to date? It's really easy to forget to update those if you change some text in the dev tools. And also we do things like, does this change? In Google, we call them change lists, but they really are exactly the same as GitHub pull requests. Does this change have a bug attached to it? Is there a bug report that's now fixed because of this change? And can we make sure we link those two together if we ever need to look at this again? So if you do not enforce whatever rules you want your team and your code base to follow, they will not be followed, just because it's hard to follow them. It's hard to remember. People have a lot going on in their heads. So take that work out of their heads and put it into the computer. A big part of what we do, and I think most teams do, is code review as well. In any given week, I'm writing code myself, but I'll also probably have to review a bunch of code that my colleagues have changed. And so when I'm reviewing code, what I want to make sure is that I'm looking at the bit I, as the developer, as a human, can best do, and I'm offloading everything else to the computer. You'll notice there's a bit of a theme throughout this talk, which is basically get the computer to do as much as possible so you can focus on the bits you as the human are best at. So take this typical, whatever change this was, I just screenshotted this today, and look at all the things that the computer is doing for me. Now, not all of them will make sense sort of outside the context of working on DevTools, but you can see we've got unit tests, we've got ESLint, we've got localization, we've got end-to-end tests, and we have some what we call interaction tests, along with a bunch of other stuff as well. Now, if you're one of my colleagues and you upload a change, everything here that this bot is doing for me, I don't have to think about. I can just forget. I don't have to think, do these changes fit with our ESLint style guide? Are the unit tests definitely going to pass with this change? I don't have to think about it at all because the computers are doing it for me. Which of these things would you rather focus on when you're reviewing code review? Hey, I would actually prefer this to be indented by 3 spaces, not 2. Or what's the reason for calling event.prevent default there? I'm finding this card hard to follow, so it might be worth exploring alternatives. That top quote, if I find that I'm having to leave pull request comments to do things like formatting, that's a sign that our tooling isn't in the right place, because a computer will do this far easier and far quicker than I will. And once we offload all that work to the computer, I can actually take my time looking through the code, sort of seeing how, if I can understand it, making sense of the architectural decisions the developer has made, looking at the naming of functions, making sure that it sort of fits in my head. And that's the bit that me as a developer, I can do because I'm familiar with the code base. I don't need to spend my time looking at formatting. That's a job that we can offload to the computers. So there's one takeaway from this talk. It's push as much stuff and tooling at the computer so that can be automated, because then what it does is it just gets out of your head. You then don't have to ever consider it, and you just know that the computers are doing it for you. I've also learned over the past year that there's only so much that you can plan when planning how to build new features or update existing features. Now, this isn't me saying that you shouldn't plan. The plans have been very valuable, but you do have to be pretty flexible in terms of suddenly hitting unexpected roadblocks. The bigger the code base, and particularly the longer the code base has been around, the more developers have touched it and added features and made changes, there's more chance you're just going to find something unexpected that stops you in your tracks a bit, regardless of how well you planned. We did a whole talk on this at the virtual Chrome Dev Summit, which was December last year. And I will share the slides afterwards, so don't worry about grabbing the link. But if you're interested in the life cycle of migrating and modernizing dev tools from sort of 15 years ago JavaScript to TypeScript to modern JavaScript, there's a whole talk on that, which, as I said, I'll share the slides. So there's much more information on this particular bit in this talk that I did with 2 of my colleagues. When you're working on a new feature on a big code base, the graph of progress is never going to be straight up and to the right. It's never going to be that easy, unfortunately. That's just how it is. That's just software. Things go wrong, bugs happen, libraries get out of date. There are so many things that can get in your way. So be ready for your progress not to be a straight line, but to have ups and downs as you progress on building your particular feature. You might start off really well, land your first change, have really good momentum. And then suddenly there's something unexpected that stops you. It invalidates the plan you made. So you need to go back and think about that. You will hit these setbacks. And when it sort of first started happening to me when I was working on this code base, I got really frustrated with myself that I hadn't spotted these things. I haven't done a thorough enough job of figuring out what the problem is. But actually, over time, what I've come to realize is I'm actually pretty good at planning things out and spotting where the flaws might be. But on a code base that's big, that you haven't necessarily worked on for a long, long time, there's just too much to spot. Ultimately, you cannot load the entire DevTools code base into your head because it's too big, or any sort of code base of that size. There's just too much going on. You cannot possibly think of everything at all the times. So plan as well as you can, but be prepared to just have to dive in and find out. And it really is finding this balance of planning versus doing. You need to hit a healthy sort of mix of both. There will be some projects where it's best to plan ahead of time, do a lot of research, structure what you're going to do, think about the process you're going to go through. But there are going to be other projects where you actually just need to dive in and do it and find out what breaks. Sometimes you want to do lots of planning. Sometimes you want to just dive in. Often you want to be somewhere in the middle. And you'll sort of I found I've got a knack for figuring out for any given project what I need to do. But trust me, that those knacks of knowing what to do only come from a lot of failures and a lot of times where I should have planned more and I didn't, or times where I spent 4 weeks planning and then it all went out the window on day 1 of coding because I realized I'd missed something crucial. So you will get there. You will make mistakes. It's not because you aren't a good developer. It's just part of the sort of process of being a developer day to day. So related, you have to be flexible to changes as well, both in terms of plans that you've made that might now have to change, or code review where your reviewer might point out a really good thing that you'd forgotten about. The only reason they know that is because they happened to work on this other feature 6 months ago, and they remember that it has this quirk that you need to be aware of, but you didn't know it ahead of time. So you will get these where suddenly you think you're done, and now suddenly you've got a few more days of work ahead of you because this thing just popped up suddenly. Sometimes it's good, sometimes it's bad. Sometimes it's some weird legacy decision in the networking module, which means we need to revisit how we're going to migrate that and modernize it. Sometimes, other times though, it's good. Oh, it turns out this bug isn't as severe as we thought for these reasons. So you do need to be flexible. Things can suddenly be better than they seem. They can be worse than they seem because you find some unexpected roadblocker in the way. Just be prepared for that. And finally, what I'll end on is, I think this is true of all software, that things always take longer than you think. But in my experience, as the code base grows and the more people work on it, this just becomes more true because there's just more going on. As the code base grows and the company grows, there are just more people working on stuff. There are more teams that will probably have different goals to your own team. There are more features, not only features you have to build, new ones, but features you have to maintain. Unfortunately, there are more bugs. The more features, just literally the more code you have, the more bugs you have, because bugs can't exist without code. So you will introduce bugs. However good you are as a developer, however good your checks are, however good your code review is, bugs are going to get into your application and you will have to deal with that. And of course, there are just more lines of code. And what all of this adds up to is more risk. The more often you make changes to your code base, the more often people make changes, you review code, it lands, that you're introducing more risk that something will go wrong. But if we didn't want to have any risk, we would just never deploy any code. So we have to have risk. We can't avoid having it. But what I've learned over the past year of working on this code base is there are a number of things: the tooling, the focusing on the code review, planning when you need to, but diving in when you need to, you can reduce the risk. And so day to day, I'd suggest, if there's one takeaway from this talk, just have a think about how can you reduce the risk of making a change in your application? Can you add in some ESLint, as Chris showed us? Can you improve your unit testing? Can you move more things out of your head to doing code review and have a computer do it, a bot do it when you upload a change? Because if we can reduce the risk, then it frees us up to spend more time building features and focusing on the good bits rather than dealing with bugs and regressions and sort of the less enjoyable side of software. So that's all I've got for you. Thank you very much for the invite, Jonathan and co. Thank you for listening. The slides are down there, jackf.io/talks/large code bases. I blog as well, jackf.io/blog. And if you're not fed up of my voice in your ears, I also do a podcast with a lovely chap called Phil. It's called Fish and Scripts. I don't really know where the name came from. We like fish and chips, and it kind of sounds like that. It's not good. We're about to launch season 2 soon, but there are old episodes up at the moment. So it's entirely free. Feel free to give that a listen, and you can grab me on Twitter as Jack_Franklin. And with that, I don't know if there are any questions. I'm happy to chat. So thank you very much.
Thank you, Jack. That was a really great talk. Really enjoyed it. So we do have a number of questions for you. So the first of which is casting your mind back to when you first joined your team. Obviously, a lot of the code had already been written with that before you were there. So how did you approach getting to grips with such a large code base?
That's a really good question. I would say it's really hard. And everyone has different ways they like to do it. For me, when I'm working on new code base, I just like to start making changes because for me, that's how I best pick up sort of what I need to do and what I need to learn. There was, and there still is plenty of documentation on how different parts work. And I know some people who, when they join a new code base or company or team, will spend a long time reading that documentation. That doesn't work for me. I need to dive in and have the documentation there alongside me to sort of see how it's going. So what I need to do is in my first week, I had a small change to make. I think I had a bug to fix. And so making that bug fix, it helped me know how to even get the code base up and running locally. That's sort of the number one thing I want to do, is be able to run the code on my computer locally and get my editor set up, etc. And so to fix this bug, I had to write a unit test. And that meant I needed to learn how to run the unit tests and how they worked. And then at that point, I needed to dive into the code and just figure it out. And everyone's process here will be slightly different. Mine is to abuse console.log and log nearly every single line that I need to figure out and just look at the console. I know there are people far better at debugging than me who use like the debugger and step through their code. just my head doesn't work like that. I don't know why. I just console.log absolutely everything until I've figured it out. So yeah, I like to dive in head first, but I think over time people will find that there are different approaches that work for them. And what I would say as well is I wouldn't, as code bases grow, as I said, you can't keep it all in your head. Like no one knows all of it. So pick a little bit and become sort of the expert on that bit. And then you can branch out over time. So I can't remember what area it was, a particular sort of panel in DevTools was the first area I happened to work on. So I put all my energy into being really good at that panel and understanding how that worked. And then over time, I've sort of brought in more knowledge as I've worked on more different bits. And sorry, it's a long answer, but finally, I would say be patient. I struggle with this. I just want to get in on day one and know the code base and be really productive. That's just unfortunately not how it works. It does take time. I'm a year in, and I still feel like I'm like mostly productive, but have still got plenty more to discover. So it will take time, but you will get there in the end.
How many people are in your team, and is there multiple teams working on DevTools, or is it one big team?
There are multiple teams working on it. I don't know the exact number of people. It's a fair few, spread out across all the different parts. So there's the core DevTools team. Then you've got things like Lighthouse and more teams who focus on the performance side of things. I'm probably forgetting a whole lot of other teams as well. But I think if you look at the commit history on the repo, you'll see there are pretty much commits rolling in all the time. So it's a lot of people, to the point where I don't even know like half the people who contribute to it. It's big.
So on large code base, how do you plan for those longer term architecture change? So for example, say that hell froze over and you decided to migrate everything to React.
Good question. So we actually just finished a year-long migration to migrate the code base to being checked by TypeScript. And so with a migration of that length, what you need to do is figure out, is it worth it? This is a big time sink. Is it going to be worth it? So we had sort of almost like prove to ourselves and to the sort of, the business and management and all sorts, what the current problems are, what we think will be solved. And then what I like to do with any big migration is try and prove it ASAP. So we knew we wanted to migrate the whole code base to being TypeScript compiled. So what we did is we picked one quite complicated file to work on, and we migrated that single file to TypeScript. And we did the bare minimum to get that single file migrated, if you like. And then we could directly compare, okay, how hard was that? Was it really easy? Are our assumptions about this spot on, or are they way off? And actually, after doing this, is it worth it? Is working on this file with TypeScript a better developer experience? Are we going to have more confidence in the code base? And from that, once you've sort of done that once, you can validate if the migration generally is definitely going to be worthwhile or not. And then after that, it's figuring out, actually, the hardest part of a long migration for me isn't the technical side. It's how do you motivate a team to do a migration piece that will take literally a year. And that is tough because I got so sick of loading up a file, changing it to TypeScript, dealing with the type errors, committing that change. I migrated a couple of hundred files, maybe. I had colleagues who migrated way more. I don't know how they managed to do it. So what we did, and we talk about this more in that YouTube talk, which I'll link to, is we had a graph online of the lines of code we had left to deal with in the migration. Once we had that, we could then plot an estimate for the end date. And I think we plotted the estimate. Bear in mind, we were aiming to get it done in 2020. We plotted the estimate and it put the finish date at November 2021, which is when we realized we weren't going quick enough. So at that point, that almost gave us the new momentum. And then in a few days, we got it from November 21 to April 21. And I was like, okay, can we get it to 2020? Then we got it to like New Year's Day 2021. And then we got it to Boxing Day. And we're like, well, we're not finishing this on Boxing Day. So sort of having that end goal really motivated all of us to pull it down. And we got it finished before Christmas, which was a nice way to end the year. So I think, yeah, the longer the migration, it's not just the technical concern. It's the concern of like, how is the team feeling? Are they up for doing this? Because the worst thing you can do is migrate something and migrate 50% of the code base, because then really you've just got two separate code bases. So I would say think about the team aspect as well as the technical aspect, which you can hopefully prove early on and roll from there.
Yeah, sure. We're currently doing a migration as well, so I can definitely relate to that. Do you so as well as all the tests and stuff and things you have when you build things, do you have like monitoring in place in production where you're able to see if users are experiencing a higher number of errors?
I believe we do. It's not something I actually have found we need to look at fairly often. I think the good thing about building something that whose target is developers is they are very good at letting you know when things are wrong. So our bug reports, which are public, so anyone can report a bug in the dev tools. Um, they are very up to date. We have a lot of people find bugs very early on, and I mentioned earlier we ship every day to Chrome Canary, and basically when you ship a change to Chrome Canary, it's got 6 to 8 weeks before it makes it into Chrome stable, and that gives us a long period of time to pick up on issues. So we do have it, and I believe it's used by people to sort of highlight potential issues, but our bug reports tend to be very reliable for us. And what we'll also do is if there's a bug comes in and it's, a bug we think, oh, this is a pretty severe bug, we should have caught this, we will add either unit tests, end-to-end tests, some other form of checking to ensure that a bug that severe in that particular area can't make it through again. So that's really nice because every time you get a bug, you can fix the bug. Then you can also make sure that bug never occurs again by adding an explicit sort of check or a test for it. So that tends to be the approach that we use that works quite well for us.
Cool. So how do you ensure that the error messages you get from all this tooling that are useful when the tests fail, so devs know exactly how to fix it?
Really good question. Part of that is about writing good unit tests. So that's things like adding like nice descriptive messages, like it and then a string, making sure that string is clear and describes what the test is doing. The main thing I found is using the right assertion functions. So most test frameworks will let you do is equal or like is what other ones, is of length X or is an instance of some class Y. And so if you can use the right assertion messages, what you can do is you can actually get those assertions to be really descriptive. Whenever I'm writing unit tests, I like to make them fail on purpose to see what the output is. I generally do that nearly every time I write a test. And so that's been a really nice way to spot if I've written the test in a way that means the error message is unclear. Or similarly, if I do, if we do get a test failing on a change, I will, if I can't figure out what the error message is, I will try and improve the error message. Another thing we found is in your main code base, if you need a certain variable to be present for some code to run, rather than sort of just early returning without throwing an error, we'll try and throw quite descriptive errors. We'll say like, cannot proceed because variable X is not defined and we expect it to be defined, or something like that. Basically, you want to think, if DevTools is entirely broken, it's just stopped working for everyone because of this error, how do we make that error as quick and easy to understand so we can fix this as soon as possible? And so I try to keep that in my head and think through that as I'm developing.
So you said about there's a lot of automation. Has it ever gone wrong with so much being? Oh, you handle all this to computers, right? So like humans are writing these rules, and humans make errors even if computers don't. So like, how do you handle that, and has it happened?
It does happen. Thankfully, nothing too severe. I think the most severe I can remember recently is we realized that one of the custom ESLint rules I'd written was only picking up the correct thing about 50% of the time for sort of some boring reason, a bug in the ESLint rule I'd written. So for things like that, all we can do is fix them, and we actually now write tests for our ESLint rules to ensure that they are working. So we're testing the linting that's testing our code base. So it gets very meta and confusing at times. But you're right. At some point, there is a risk when we automate. The main thing though that we do is we don't. There's nothing automated that could severely break. The worst thing that will happen is we'll miss some ESLint rules and we'll miss some unit tests. Even missing unit tests is incredibly unlikely. So really, there's not much you can do other than keep an eye on it and sort of deal with it when it happens. That's really it. I guess the fact that I've been on the team for a year now, and the worst thing I can think of is we missed some ESLint violations. I think that's probably a pretty good sign that we're doing it okay. There is a good story from a previous company where, so we had, I don't know, say 1,000 unit tests on our entire code base, and every time we deployed, we would run all these unit tests. But In most JavaScript testing frameworks, if you've got like an it test, you can put it.only. You can change the it to it.only. And what that does is it tells the test runner, okay, ignore the other 1,000 tests, just run this single test. And I like to do that if I'm working on a feature. I'll only run the test related to that feature. But what I did is I forgot to remove the .only bit before deploying to production. And so for about a couple of weeks, every time we deployed, we thought we were running all the unit tests. It turned out we were only running one unit test out of 1,000. Thankfully, they were still all passing, but that could have very easily led to us having issues because we'd broken tests and didn't know about it. The fix there was to add an ESLint rule, which errored if you used it.only, and that prevented the issue from happening again. So yeah, there is a bit of a risk. As I said, you can't get rid of it. But normally, if you're on the ball and you keep an eye on things and you use tools like ESLint, and don't let the computers automate absolutely everything. Every change we make still needs a human to read it and approve it. Hopefully, you'll be okay. But again, it's about striking that balance.
Cool. So you talked about how planning can be really difficult on such a big code base. So how do you estimate as a team?
Good question. Badly, I think, is the answer. We've moved away from trying to be super accurate with our estimates. We normally plan roughly a quarter's worth of work or 3 months worth of work at a time. And I think one of the things that we're quite fortunate is the nature of the work we do is we very rarely have a strict deadline on any particular feature. Because Chrome ships every 6 to 8 weeks, there's no point having a strict deadline because it won't make it in necessarily until a certain point. And so for us, we try to estimate, like, is this a couple of weeks or is this a couple of months or is it kind of somewhere-ish in between? But we're quite fortunate that we don't have to stick to very hard deadlines a lot of the time. So that makes it a little easier. But I think that TypeScript migration, we initially estimated 2 or 3 months and it took a year. So we're not very good at it. But I'm really coming to the sort of understanding that estimating is nearly impossible. And so the more hand wavy you can be, kind of the better, because every time you try and be more accurate than that, you're just going to be wrong. And so, yeah, we estimate at a very, very high level, like, is this going to be weeks or months? And that's largely it, because we're not very good at it. It's my honest answer.
Cool. One last question. So at this meetup, we've had speakers from like Edge before talking about the Edge dev tools, and I was just wondering, like, how does your team interact with the teams at Edge and Samsung Internet who are also contributing to Chromium browsers?
Yeah, so we've collaborated with them on a fair few features that made it into both Edge and the Chrome DevTools. We interact a fair bit as I said, if we happen to be working on a similar feature. But other than that, really, we interact just like different people contributing to the same code base. So Edge, I think they have their own fork of the Chromium DevTools, the repository I showed at the beginning, but they contribute features back to that. We review them. I've asked people from Microsoft to review one of my changes that happen to be on an area they'd worked on. So it's fairly informal, but yeah, we do chat and collaborate on features when it makes sense to.
Cool. That's great. Thank you for your talk.
No worries. Thank you.
If you'd like to stop sharing your slides, and we'll just share our last
sure.
slides.